Okay, so if you're joining us for the first time, this event has been organized by Nairobi DevOps community, and I'd like to welcome you. And we are going to tell you about Nairobi DevOps community in a few minutes, maybe 1 or 2 minutes, and then after that, our speaker is going to speak. So our speaker for today is Ian Koome, who is a senior site reliability engineer. So he's also probably going to tell us what site reliability engineering is, so that we can be able to. So, but first, we have a quote here, which says, "Every step counts." So, no matter how little the step is, that step can add on to something. So, several little steps can lead into one big milestone. So you don't have to make one big step for you to get there, or big steps. So you just go with the steps that you can manage, and you can be able to get where you're going. Yeah, and this is not just about walking. So it's just in anything you do. So the effort that you put, your best. So no matter how small your best is, so long as you're putting your best, you will eventually achieve your goal. So on our agenda, we are going to start with an icebreaker. And then after we are done with the icebreaker, we are going to learn about the community. And then after we learn about the community, we are going to have our speaker, Ian, take us through an opinionated approach to setting up your infrastructure as code, which is a topic that he covered during the DevOps Days event. But since some of the people did not manage to attend the event, so we thought it wise to redo the session and have it on our YouTube channel so that guys can be able to access it there. So after the session, we're going to have Q&A session. But of course, in between the session, you can post your questions on the chat, and I'll be able to read them out loud so that Ian can respond to them. So we've removed the abilities for you guys to speak by default and sharing video because of being spammed previously. And so we are just trying to ensure that everyone can have a good experience. So we limit you to putting your questions on the chat. Yeah, and then I'll be able to read them out. Also for the icebreaker, you'll just be participating on the chat. So we move on to the first item, which is the icebreaker. So would you rather inherit or create your own wealth? So you can respond on the chat. I'm looking at the chat. Would you rather inherit or create your own wealth? So I can see Victor has already responded, saying create your own wealth. Anyone else? We have anyone else? Steve Maina, inherit. And then you can also try and say maybe why. Why do you think that is the best option for you? And then I can see there are more comments here. John saying inheriting ikiwa siezi acha. So if the inheriting option is available, he's going to choose that option. And then Dennis says create on wealth. Yunus says any is good for me. Inherit, then multiply the wealth. And then Rogers, inherit option. If inherit option will be there, I will choose that. So you have to choose one. So you either inherit or you create your own. So let's say you don't know what you're going to inherit. And you also want to create your own wealth, but you do not know where to start. So you are just a clean slate. So you are thinking, responding from that angle. Okay, so I can see the more here. Cohen says inherit, then multiply the wealth. If inherit option will be there, I will choose that. Wahome, create your own wealth. So I think those are a good number of comments. So I think for myself, I'd choose creating my own wealth in the position where I do not know who I'm inheriting from. or what they have. But if I knew what their wealth is, I could just inherit that and create my own wealth using that what I've inherited. So let us move on. So about the community. So Nairobi DevOps community is a community that started last year on 15th April. We are about 1 year and several months old, probably 1 and 2 months old. And we are just a community made up of DevOps enthusiasts. And DevOps enthusiasts are just people who are both experts and learners, and all of them are seeking to network and grow by collaborating and also learning from each other. So our mission is just to create a supportive and inclusive community that values diversity and supports learning and growth. And our vision is to be a leading DevOps community in Nairobi and beyond, driving innovation and empowering professionals to excel in their careers. In case you want to help the community grow, what you can do is you can help us in participating in running workshops or talks that come easy to you, things that you're already conversant with. You can also connect us with other professionals who you think can add values to other community, add value to other community members. You can also give us feedback and ideas on things that we can work on in order to make people in the community have a better experience. You can also share the things we post on our channels, and you can also share your own content or information, things that you think other people can benefit from. You can join us and help us in organizing our events and also in branding. There is a lot that goes into ensuring that we have the events. So we need to create posters, we need to find speakers, we need to follow up with them, we need to ensure if they've created slides, we need to ensure that they are good quality and such things. So we need support in all those areas, and we welcome you to join us in such. So now, in case you're not in the community, you can scan. So the first one is LinkedIn. You can join, you can follow us on LinkedIn if you scan the QR code. You can also join our WhatsApp group. So you have one WhatsApp group that is full. So this is the second one. You can join it. It's around 150 people, I think now. But you can join it before it's full again. So then you also have Twitter. So you can actually follow us on these platforms. Even if you're on one, you can follow on the rest and join the rest as well, so that you can just interact with the different people on these platforms. So having said that, in case there is any question about the community, you can type it on the chat, and then I'll be able to respond to it as the speaker carries on. So at this point, I would like to invite our honorable guests, Ian Koome, to take us through the unopinionated approach towards setting up your infrastructure as code. So Ian, welcome. So I'll stop sharing, and then you can just share and pick up from there.
Okay, thanks, Sam. As you've heard, my name is Ian. Let me just share my screen. Just share the screen. As you've heard, my name is Ian. I'm a site reliability engineer at CloudKite. So the difference between site reliability engineer and DevOps is that in site reliability engineering, we are more concerned on uptime, reliability, scalability, and things like those. While DevOps is more about the automation, CI/CD, Docker containers, and all that. We use the terms interchangeably at our company, which is CloudKite, but most people use them interchangeably. But it's one of those things that really have no difference. if you're a site reliability engineer, you can also work as a DevOps engineer, and it works that way. So my topic today is on an opinionated approach to setting up your ISC. The reason I came up with this topic, or we came up with this topic, is that when starting to set up your infrastructure as code, there's a lot of confusion that, or a lot of questions that you may ask yourself. Is should I have my ISC in one repo? Should I separate my environment using branches? Should I have my ISC in multiple repos and stuff like that? Reason being is that there is no standard approach to setting this up. In the case of applications, you have frameworks like Django, Flask, Phoenix for Elixir, which will help you like have a standard structure to set up. But when it comes to infrastructure, there is really no standard structure or set of best practices that you can follow. So some of these concerns when setting up your ISC include the structure for your infrastructure as code. Should you have it as one repository for your Terraform? Then in the case you're setting up Kubernetes, should you have your Helm charts or Kubernetes manifest in another repo? Or should you combine your manifests together with your application code? Also separation of application configuration, basically how should you separate your configurations by environments, separation of Terraform resources by environment, how you manage your secrets, then how you ensure your workloads authenticate to cloud resources, and your CI/CD setup. So I'll go through all of these cases. So in our case, we use a single repository approach. So we usually have the infrastructure as code for a particular company in a single repo. That makes it easy to like sort of manage instead of multiple repos. So in this case, we have Kubernetes Helm charts and Terraform in one repo, which acts as a single source of truth and provides ease of management. So I'll also speak more on this later. Also, we have Terraform in the same repository. So the Terraform you basically use the same Terraform resource blocks across environments, and difference being in the variables in the environments. So we ensure that our Terraform is like you only have one Terraform. If you're creating, for example, a Kubernetes cluster, we have only one Terraform resource for the Kubernetes cluster. So like, for example, AKS, one Terraform resource for that, and that resource is used across environments. Of course, in the different environments, you have different state files. So it's just a code that is shared. Then for Helm chart structure, we have usually advocate for building your own Helm library. So, for example, if you're using a deployment, Kubernetes deployment feature, so you write the deployment, then when you're defining the Helm chart for the particular application, you just include it. So on the left, I've shown how, for example, an example of a standard library for a Kubernetes deployment, and on the right, there is how you include it in your Helm chart, particular application. So this makes it easy for making changes. So for example, if you want to add a feature to the deployment, such as annotations or basically a feature that's not defined in the deployment, then you'd only need to add it to one place. This is in a case where you have like maybe 10, 15 microservices or something, then you only add it to one place, and then you upgrade your library, your Helm library, and you have the changes. In this case, your shared library can be hosted on ECR or any container. Even you can host it on a GitHub. Sorry, yes.
So here I'm seeing people are saying that they cannot see slides you're referring to. Do they mean you're still on the first slide?
No, I've been shifting slides.
Oh, you're still, yeah, you've been sharing you're still on the first slide, so it's not moving.
Or really? Let me just. I've been moving slides.
Oh, okay. So it seems probably you shared the wrong screen.
Can you see my screen now?
Yes, yes.
Does it show the slides?
Yeah, yeah, yeah.
So I'm on the Terraform structure slide. Does it show that?
Yeah.
Okay. So now I'm on Helm chart structure.
But you can
So
just
what?
you can brush through the ones that they missed so that they
Okay.
can see maybe. Yeah.
So on the single repository approach, it's just the Kubernetes Helm charts and Terraform in one repository. These are just Helm charts with Helm values file and Terraform resource blocks.
So
So
maybe you can
I'll repeat
present.
this.
Yeah,
Yeah.
yeah, yeah.
On the Helm chart structure, as I said, on the left side, there is a deployment, which is a shared resource in the library. So, for example, if you have 5 microservices in Kubernetes, or 5 services, then you need to define 5 deployments, right? So if you wanted to make it easier for you, you should just write a standard library. Then you use a library in the Helm chart for the particular application. Then
So
you
there is
define. Yep.
so the code is too small. So maybe
Okay.
if you put on presentation mode, it will be visible
Okay. Let me just try skip.
or zoom in.
I don't know if is it still too small.
Yes, yes, yeah. Nothing has happened from our end.
And now,
Still nothing. So maybe you can try presentation because we are
yeah.
only seeing we are seeing the slides on the left and we are seeing the Terraform. So the presentation is like the main slide only appearing on the screen, full screen.
Okay. Okay. Dismiss. Is that presentation mode on?
On the slides itself, on the slides themselves.
Yeah, that's what I'm using.
Like, yeah.
Yeah.
So go
So
go back to the slide.
if I click on play, that's what it
Mm,
shows.
now we can't see anything. So back on the slides, and then you look for a place where you can present that individual the slides, the slideshow.
Mm. I usually use play.
Oh yeah, try that probably.
Okay. That's what I've been using.
Okay, or you share your entire screen. Probably that will, if you're sharing a tab.
Yeah, I've shared the entire screen actually.
Okay, you can go to the slides. We see. We can maybe
Mm.
zoom in or do something.
Does this work now?
So currently we are not seeing the slides. We are just seeing the meeting itself.
And now?
Not yet, unless you stop presenting and then you present again.
Okay, stop. How about now?
Yeah, so we can see, but probably, yeah,
And now?
that's what, yeah, exactly.
So
Uh,
yeah,
so is that visible,
uh,
guys? So I think they're fine. So I can proceed.
okay. So this is a Helm chart structure. So as I said, on the left, I define the shared deployment resource. Then on the right, that's how you include it in the Helm chart library. This helps in that you can just have ease of management of your Helm charts, such that if you want to, let's say, update something, you only need to update one place and do an upgrade on your Helm chart library. Then you just reference it in the chat.yaml of your individual Helm chart of the application. Then we have, I hope you can see my new slide now.
Yes, we can.
Okay. Then in terms of environments, we separate them via different values file. So the common configuration lies within the Helm chart library, or the resources you choose to include in your particular application. Um, particular application. Then whatever is not common, we define that in the values file. So we have a different values file per environment, dev, staging, prod, and so on. So for the Terraform structure, we advocate for use of Terraform modules. And while you're using resource blocks, make sure you repeat them. So as you've seen, in this Terraform, we don't repeat resource blocks. Basically, if you want multiple, for example, AWS IAM roles or users or policies, then you define them in your variables, and on your resource block, you just loop through them and create them. So it makes it quite elegant when reading through the Terraform code. Then I'll head over to secrets management, which is also an issue that many people deal with when setting up the infrastructure. So in case of secrets, we require a single source of truth. Cloud providers provide secret management solutions. So AWS provides secrets manager. In the case of GCP, you have this secrets manager as well. Then in case of Azure, you have. So these are solutions that are secure and safe to store your secrets, and you can assign permissions on who can access these secrets. So in the case of if you have your infrastructure on Kubernetes, then we advocate for the use of external secrets. So what external secrets does, it's able to connect to your secret management solution, and you're able to define the secrets you want created on your cluster. So you allow external secrets access to AWS Secrets Manager with the right permissions. Then within your individual application Helm charts, then you define which secret you want to be mounted in that case. So for example, on the screenshot I've shown on the left, that's how we define the external secrets on our values file, and we're able to retrieve that, and that will create a secret. So for example, the secret which will be created will be the name of the Helm chart, right? So it will create a secret, for example, something like an API. Helm chart, let's say it's called API. So the external secrets will create a secret called API, and it will be able to pull the API key from AWS Secrets Manager, and that will create a Kubernetes secret, right? Then from your Kubernetes workloads, you can reference those secrets. Right? So in this case, there's no need to store any secrets in Git. The place where you store your secrets is only one single source, which is your cloud secrets management solution. Then in the case of authentication to cloud resources, this is also something that people think about when setting up. The case where you have, let's say, a service that wants to write reports to S3, or you want to authenticate to Kinesis, or basically authenticating to any cloud resource. In this case, We advocate for the use of workload identity. I'm sure many people use AWS Access Key ID, Access Key Secret, and just set those as environment variables, and then have your application read that and authenticate to the cloud resource. That isn't secure because it's like having static credentials, right? And if anyone has access to those static credentials, um, even if it's a former engineer of where you work, then even once they leave, they also have access to your cloud resources. So the recommended way to authenticate to cloud resources is by a workload identity. So how workload identity works is that it just gives you the required credentials for a short period of time and keeps on rotating them, right? So once you configure workload identity, which I'll show in the following slide, um, a token gets mounted on your pod, on your Kubernetes pod, for which is used. So the token gets mounted by, in the case of AWS, it's EKS pod identity webhook, right, which is the application AWS uses for workload identity. So once you define an annotation on your service account with a role that you want the workload to use, AWS will mount the envs that I've shown on the slide, which also includes a web identity token file, right? So when now you use the AWS library to authenticate to a cloud resource with application, what happens is that you send a token. So what happens first is a token is sent to AWS IAM, right? So AWS IAM looks at the token claims, and if they're valid, so for example, if they're valid, it checks on the OIDC provider. In this case, the OIDC provider is defined as your Kubernetes API, and checks against those claims. If they're valid, then IAM will send another token back that you'll use to access the cloud resource, right? So in this case, I've shown you just define an annotation on your service account, which is associated with your workload. And the pod identity webhook will mount the token files. And then you just use the AWS libraries, in this case, to authenticate to cloud resources. So anytime these tokens actually have a lifetime, so that's what makes it secure. So anytime it expires, the whole process starts again. You use a token the web identity token file, make a request to AWS IAM responds with another token, then that's what you use to access your cloud resource. So in this case, there's no fixed credentials being used to access your cloud resources. In terms of CI/CD setup, we usually use GitHub Actions and Argo CD for CI/CD. So GitHub Actions builds image and pushes to container registry. Then you have Argo CD syncing your latest changes. So GitHub Actions, some people say it's not cloud native, so you might end up using people may choose to use cloud native solutions such as Code Deploy or other solutions, but GitHub Actions of late has proved to be quite secure because they also have OIDC connection to your AWS, so you don't have to hard code credentials. OIDC is basically this whole process which I'd explained here. So you can just use a role, and that's all you need to a role, and you set up GitHub as an OIDC provider in your AWS account, and AWS can now trust GitHub Actions. Yeah. So in this case, you just tell AWS trust this repository, also the repository organization and repository name, and now you can give permissions to GHA to push images to your ACR. In the case you require also to read secrets, secrets manager, you can do the same. So also use the concept of using libraries, like in the Helm charts, we also use it in GitHub Actions, where you define one main GitHub action used by all applications. Then all you pass is different variables required for your CI/CD. For example, in the build job I'm showing, that's a CloudKite public GitHub action, which you can also use for your CI/CD. So in that case, I just pass the AWS account ID, AWS region, ACR repo name, which also may be the same as the application name, and the AWS role name being used. Then that builds an image and pushes it to ECR. And in the deploy job, which depends on the build job, we pass the AWS account ID, AWS region, ECR repo name, then infrastructure repo. So if all you're familiar with GitOps, you know that the GitHub actions will commit, or your CI solution will commit the latest image tag to your configurations, then Argo CD will sync it. So in this case, we tell the GitHub actions which infrastructure repo to commit to, and the name of the app and the branch in that case. So the branch of our infrastructure repo, and that job just commits to the repo, which is connected to. So there's a deploy key which our GitHub actions has access to, so that it can push to the repo. That deploy key can be in secrets manager as well. You don't have to have it in your GitHub secrets, as is shown here. So for the sample walkthrough, I have a repo which you can go through at your own time and ask questions. It's actually public, so it's just Terraform in the case of AWS with like 2 sample microservices. In the case of a shared library, in the case of CI/CD, these are also public. So the users, the CloudKite, if you just go to the CloudKite repo, then you'll find a public repo known as GitHub workflows. Then you can see all the shared workflows that we use. You can also use them or contribute. So in case of any questions, this is how you can reach me. Just by my email, LinkedIn, and Twitter. I think I can take any questions now.
Okay, great. Thank you for the insightful presentation. So let me check for questions. So guys, you can post your questions on the chat. So any questions you have for Ian, so that he can respond to them. So Yunus Arif has asked, do you create secret in Secret Manager through Terraform? If yes, where do you put the value?
We create secrets in Secrets Manager through Terraform. If we can, I'll say it how. If we can obtain the secret from Terraform itself, right? So for example, you're creating a database user, for example, using the PostgreSQL provider, and use a random password in Terraform, which is a Terraform resource, to generate the password, right? Then if you have a secrets resource in Terraform, you can simply reference the random password. Like so, you'll reference a random password value. So there is the value of the secret can be obtained from a Terraform output, right? So in that case, we'll create the secret via Terraform. But if that's not the case, we just input it manually to the secrets manager.
Okay, thank you for responding to that. Yunus, you'll confirm on the chat if you feel answered. There is another question from John King. He asks, if at all you've worked with Yoke, do you recommend it over Helm? I'm new to both.
I haven't worked with York. Actually, I'm hearing it for the first time here. Maybe I've heard it before, but I forgot. But I think Helm is the most widely used package manager for Kubernetes. In terms of even open source, all these open source applications, Argo CD, they have their own Helm chart, Argo workflows, kernel secrets. So it makes it easier to work with Helm due to the open source support that is there. So we work
Okay.
yeah.
Okay, so if there is anyone who has worked with Yoke, maybe you can raise your hand and then I give you the chance to speak. So if is there any other question from anyone? Any other question from anyone? Okay, so if there is no question, then we can look out for our next event that is going to happen next Sunday, same time, 8 p.m. So every week we'll be having our online sessions. Every Sunday at 8 p.m. we have our online sessions, and we may also be having physical events, which will be updating you about them. So be on the lookout for that. Follow us so that you can see when we post anything. So that is it for today. And I wish you guys a good night and a good week ahead. Thank you, Ian, for sharing.
Sure.
Okay, guys. Bye-bye.
Bye.
Feel free to drop.